Hello, class. Well, today what I want to try and do is keep working on how we read graphs and how we get information from a graph. So, last class we looked at how we find domain and range. All right, so we're going to add more to that information. So, let's look at this worksheet. And as I'm doing this, if you need to pause and take some notes, do that. If you want to kind of follow through the worksheet, I will post the worksheet so that you can follow through with what I'm trying to do. All right, so let's look at the very first question. So the very first question says that you have the graph of f of x shown on the right. Each grid box has a dimension of 1 unit by 1 unit. So when I'm asked to find the domain, as I said in class, you want to scan from the left to the right. All right, that's how we want to scan. And domain is the collection of all the possible x values that this function has. Now remember, it's a function, so if you pick an x, you should see a corresponding y value. All right, so when I'm looking at this, I'm thinking about this. Okay, I'm scanning from left, so I can start from here. Right, so I can see that the graph lives from here to here. Let's examine what's going on over there. So clearly, you can see that the x value is okay all the way till you reach -1. At -1, you have a filled-in circle and an open circle. Well, so because you have a filled-in circle, it will override the open circle. So that means that there is an x value. If I wanted to evaluate f of -1, the answer will be 2 and not 3 because 3 is an open circle. So for that, I'm going to start from here, -1, 2, 3, 4, -4. And then I'm going to stop right here. I'm at what? I'm at -1. Well, I'm going to keep continuing, all right, because I have the ability to keep going on. I can keep going on, because for each x, I can see a corresponding y. Each x, I can see a corresponding y until I reach here at 2. At 2, I have an open circle. Well, I have to jump off from that 2 to continue. So I can actually break the domain that I have now. So I have -4, and it went all the way to 2 with a regular parentheses because it was an open circle over there. And then I'm going to scan again, keep going. And then when I reach 3, I realize I have an open circle and a closed circle. So the closed circle will override the open circle, meaning that you have that x value on that on that graph. So now I can continue from there and scan all the way to 4. Well, sorry, 1, 2, 3, 4, all the way to x equal to 5, which is a filled-in circle over there. So I'm going to have this as my domain union 2 all the way to 5, bracket closed. Scanning from left to right, making sure that you're capturing all the possible x values that this graph has. If you have an open circle and above it you have a closed circle, the closed circle always override the open circle so that the point, the x value, exists in that domain. Okay? All right, now let's look at the next one. The next question says find the range. So if I look at the range, remember the range represents all the possible y values. So I'm scanning from top to bottom on the graph to see all the y values that this function has. So if I start scanning, I can see that, okay, the y value is open at the very beginning over here. So right about here, the y value doesn't exist, all right? So I can start off with a regular parentheses. And then once I start to scan, you can clearly see that the point exists for, as I keep going, there's a y value for every x that I see on the graph, all right? There's that graph continues until right about here. Even though there are open circles here and here, in between, that y value exists, so I'm okay. But after that, the graph ceased to exist anymore, right? In between here, there is no graph. There is no graph over there. So I got to break this up and write the range as going from 1, 2, 3, 3, comma, all the way to -1, inclusive because that line exists over there. And then I got to break this graph, continue union, and then I can see that I can scan from here going, the graph exists. So I'm going to go with -2, -2, and -3. Okay. All right. Allison, I beg you, I'm making a video. Please don't talk. All right. Sorry for the break in transmission. I was trying to tell my daughters to be a little bit quieter. Okay. All right. So let's continue. Let's see if we can wrap up this. So hopefully this makes sense to you on how I'm scanning. All right. You got to scan top to bottom. Make sure that from the graph, you are capturing all the y values on that function. All right. Now let's look at C. C says I want to find f of what? F of 3. F of -1. All right. Let's start working with proper notation. So f of -1, I got to go to -1. This is -1. And you can see this is that. So I got to pick the right one, right? This is where the filled in circle is. This is open, all right? That is open, so I can't really find the y value on that. I can only find it on where the graph exists, all right? So this is going to be equal to -2. All right, let's look at the next question. The next question says f of what? -3. So I'm going to go to -3. That's -2 and -3. That is right about here. Now the question is, well, how do I know what that value is? Well, I just can't guess by looking at the graph. I need to know what this line is. So we learned how to find equation of a line. Let's try and find the equation of that line real quick, okay? So this point is -4, 2, 1. And this point here is -1, 3. All right, don't let the open circle get you confused. You're just trying to look for the line. All right, so we just need 2 points. All right, so here we can find m. M is 3 minus 1 over -1 minus 4. We get 2 over 3. And so writing it in y minus y1 point slope form, mx minus x1, we end up seeing that this is y minus, if I pick one other point, y minus 1 is equal to 2 over 3 x plus 4. Okay, so now that we know this, we can write this as y is equal to 2 over 3 x plus 4 plus 1. So we now know the equation of this line. So and remember that we said y is this nice name for what? F of x. I can write this as f of x is equal to 2 over 3 x plus 4 plus 1. So at f of negative 3, we're going to get 2 over 3, negative 3 plus 4 plus 1. We end up with 2/3, 1 plus 1. That's about 3, that's 5 over 3. Okay, so it's just a little bit, so 5 over 3 is approximately close to 2. Kind of makes sense that that has to be the y value. So that is 5 over 3. All right, let's look at the next question. The next question, D, says that solve for all x when f of x is equal to negative 2. So understand what this is trying to do. This is telling us that we have a y equal to what? Negative 2. So you have this function here, you're trying to find all the x values whose y is equal to negative 2. So again, if you look at the graph, the way you want to do this is you got to go look for where y is equal to negative 2 and then draw a line at negative 2. So negative 2 is right here. And you're looking for where they intersect because that's where you find where all the y values are equal to 2 so that you can find the x. And the only place where I can see this happening is right here. All right, this is the only place. So 1, 2, 3, 4, 5. That is when x is equal to what? When x is equal to 5. Okay. All right, let's go ahead and look at the next few ones that we have here. All right, again, so some new definitions. Root or zeros is another nice name for saying x-intercept. All right, so roots is the same as zeros, is the same as the x-intercept. All right, so we are asking ourselves, look for the x-intercepts, meaning you're looking for, when you talk about x-intercept, we know that y is what? 0. So we are asking you to find all the arguments whose value or output is 0. All right. So again, you go through this expression here. You're going to try and find the places where y is equal to 0. So again, y equal to 0 is this line right here. And your job is to find that x over here because that's the only place that we can see it crossing the x-axis. That is the x-intercept. So again, you don't have a clear view of what that x is. If you guess, you might get it right, but you actually have to figure out what the equation of this line is so that you can find what is going on. Okay, so let's find the equation of that line. We have that point here being 1, 2, and this point here being 2, negative 1. So let's find that line, okay? We find that line, we have m is equal to 2 minus 1 over 1 minus 2. So we get 3 over negative 1, which is negative 3. All right, we could have gotten that over here, rise over run, right? 1, 2, 3, there, negative 3. And now let's pick a point and use it to get the equation of the line in point slope form. So y minus y1 is equal to mx minus x1. Okay, so if I pick the point 1, 2, I get y minus 2 is equal to negative 3 x minus 1. All right, and if I write this as y is equal to negative 3 x minus 1 plus 2, remember y is a fancy word for f of x, is equal to negative 3 x minus 1 plus 2. So the question is saying, look for all the what? All the argument whose output is 0, whose f of x is 0. So that means that this, we're saying this is equal to 0 is equal to minus 3x plus 3 plus 2. Okay, so we end up getting negative 5 is equal to 3 negative 3x. X is what? 5 over 3 is equal to x. All right, so again, if you look at it, you can clearly see that we are just about right. It's a little bit close to 2, which is what 5 over 3 looks like. So the x-intercept, or the root, or is x is equal to what? 5 over 3. Okay. All right, now let's look at what we mean by when we say a function is increasing. So a function is increasing when, if you pick any two x values, their corresponding value, the corresponding y values is always bigger. All right, so if you pick f of what? F of a, it's less than what? F of b all the time, or you can say that f of b is always bigger than what? F of a. Remember that f of a is a value, is a y, right? So the outputs are less because this is always going to be smaller than the other one. So this is f of a, and that is f of b. All right. And then when we're talking about decreasing, we're looking at a situation where you are decreasing this way. So if I have a and b, when I look at f of a and I look at the corresponding y value, f of b, if I compare them, scan from left to right, you can see that f of b is always smaller than f of a, or vice versa. F of a is always bigger than f of what? F of b. And then the third case is if nothing really happens. That means that it's a constant. So a and b, this gives you f of a, which is the same as what f of b is. Since there is no change in the y, we say that this is constant. Okay, so let's look at this graph here and see if we can examine where the graph is increasing or decreasing. Okay, so let's look at f of x and let's see, where is this graph increasing? All right, so we can clearly see that the graph is increasing right about here. All the y values are bigger than the previous one. And then it's decreasing where all the y values are smaller than the previous one. And then increasing right here, decreasing right here, remains a constant right here, and then it's increasing right here. Okay, so by that we can clearly see that it's increasing from negative 4 all the way to 1 square bracket, no, regular parentheses, because it's on the open circle. That's where it was increasing. And then we get union 0. Well, we got to use the square bracket. 0 to 1 union, and then goes from 1, 2, 3, 3, 4, 5. Okay, so it's increasing over there. All right, and these are all x values, right? So let's make sure we are indicating that these are x values. So it's increasing, x belongs to that. And then where is it decreasing? So it's decreasing at those red places that I have on the graph. So it's decreasing when x belongs to Now you're going from 1 to 0, -1 to 0, union 1 to 2, regular bracket. All right, and if you ask for where is it the same, where is it constant, then that would be, if you're looking at constant, that would be x belonging to 2 to 3. Okay. All right, let's wrap this up. Now, when I look at the last question, which says solve for all x where f of x is equal to f of 1. You got to take your time and understand what is going on over here. We have f of x, which to us means y, and then f of 1, you have to go and evaluate what f of 1 is. So f of 1 is at 2, right? So this is 1, f of 1. So you got to go look for what its corresponding y value is, and that's 2. So this question is really saying find all the x whose y value is equal to 2. So again, you return to the graph and you're going to try and locate where 2 is. So 2 is right here. And find all the x whose y value is 2. Well, 2 of them are fairly easy to get. One of them is right here. The other one is right here. And the third one is right there. Well, this is 1. This is -1. But this is not so clear. All right. But we already found that line already. All right. That line was right here. Okay. That line is for this guy here. So we can solve this, all right? So let's look at the solution. So here, x is equal to -1, 1. And then now let's go solve for the third piece. So the third piece, we know what the y is. Y is supposed to be 2 is equal to 2 over 3, x plus 4 plus 1, all right? So we need to solve for x. And we did this last term, solving for x last term. So let's see, how do we do this? Move the 1 back, you get 1 is equal to 2/3 x plus 4. Multiply by 3, you end up with 3 is equal to 2x plus 4. Multiply through, you get 2x plus 8. Subtract, you get -5 over 2 is equal to x. So -5 over 2 is a little bit over 2, -2. So 1, 2. So we are right there. So this is -5 over 2. So we figured out the last piece, which is -5 over 2. Okay. All right, let's do the last one. I'm going to change the last one because we haven't covered this yet. And I'm going to change this to f of x is greater than or equal to 1. Okay, let's solve that real quick. Okay, so, well, let's make my life a little bit easy. And let's look at, not to burden everybody right now, let's look at the same problem here when that is greater than or equal to 2. Okay, so let's look at that inequality. So when you read this question is saying solve for all x where f of x, again, this is y, is greater than or equal to 2. So you got to come again to the graph and then ask yourself, okay, I'm looking at when y is equal to 2. That is this spot right here. And I'm looking for all the y values that is greater than 2. So anything that is below is less than 2, y less than 2, because these are the y values. And then anything that is above that line is any y that is greater than or equal to 2. Okay, So I'm only looking at the graph right about here. This is the only place that is above that line. So I'm looking at the solution. I'm only capturing this piece and that piece. That is the only window of x values whose y is bigger or equal to 2. So we already solved for this. This is negative 5 over 2. That is negative 1. So the solution to this is x belongs to negative 5 over 2 and negative 1. Well, since we are dealing with greater than or equal to, the graph really starts from here, negative 5 over 2. So I'm going to use square bracket. And then it ends at negative 1, which is an open circle. So I have to end it with a what? With an open circle. Okay. So hopefully this video gives you a little insight when I'm trying to read a graph. Okay. I think that's enough for today. We've covered different concepts. We looked at roots, looked at what zeros are, we looked at what increasing and decreasing looks like on the graph. We know how to graph other functions on the graph to interpret if you're looking at an equality or an inequality. And then obviously we learn how to trace a graph left to right, top to bottom, trying to figure out what the domain and range are respectively. And then we did a review on lines. Okay, so hopefully take your time, look at it one more time, read it, watch the video, make your own notes, and make sure that you're picking out the salient point in this video. Okay, I apologize for the little sound bites from my kids, trying to do this early in the morning, but obviously they were awake and tried to join the video. All right, I apologize for that. Okay, have a wonderful day. Bye-bye.